going to review everything we have done in this unit. So starting with arc length, I want to know how long that arc is. The formula is S equals R theta, so that's the radius times the radians. So here arc length is 3 times 1.7, and 3 times 1.7 is 5.1. It doesn't say feet or inches or anything like that, so I'm just going to go U for units. Area of a sector, so that's the area of this whole thing, is 1/2 R squared theta. So the area is 1/2 times 3 squared times 1.7. And that is 7.65, and that's units squared. Okay, next we will convert between degrees and radians. So to convert from degrees to radians, we need to multiply all of these by pi over 180. I'm not going to write that for every one of these, but 180 times pi over 180, those are going to cancel, and that is pi radians, which makes sense. 180 is halfway around a circle, so is pi radians. 30 times pi over 180. I can use the calculator. 30 over 180. And then math, ask for it as a fraction, enter, enter. That is 1/6. So 30 over 180 is 1/6. So 30 degrees is pi over 6. For 60 degrees, 60 divided by 180, math, enter, enter, 1/3. So this one is pi over 3. Okay, I'm not going to continue for each one of those, but we'll go down to G. Pi over 15 units along the unit circle. Okay, so that's pi over 15. And in a unit circle, that means the radius is 1. And the number of units along the unit circle, the arc length, if you're on a unit circle, that arc length is the radian value. So it's pi over 15. Okay, so next we are changing from radians to degrees. We have to multiply by 180 over pi. Okay, so if there's a pi in the numerator and denominator, they cancel. 180 divided by 4 is 45, so this is 45 degrees. Here we can cross out the pi's again, and then 3 times 180 divided by 2, 3 times 180 divided by 2, and I will ask for that as a fraction, and there isn't a fraction. It's 270 degrees. Okay, so pi times 180 over pi. Those cancel, and I get 180 degrees. Okay, let's go down to F. Pi over 15, but here this is in degrees, so I need it in radians. So I do need to multiply by 180 over pi. So the pi's cancel, and I've got 180 divided by 15. (12 degrees). All right, next we've got an equation that we want to graph on our test. We're going to have the factored form of this, so it's going to look like this. 3 plus 2 cosine, okay, and then that pi over 4 is factored out, and that's x plus, and the factored form is 2. Okay, so the sinusoidal axis, the vertical shift is 3. The amplitude, the vertical dilation, is 2. The displacement, the horizontal shift, is -2. And the period is 2 pi over b, So that's 2 pi over 4. Okay, so if I want to divide this, I can do an outer loop and get 8 pi, and an inner loop, pi times 1 is pi, so the period is 8. So for my graph, I've got a sinusoidal axis at 3, a maximum, and a minimum. The amplitude is 2, 3 plus 2 is 5, 3 minus 2 is 1. That means that my x-axis, where y is 0, is going to be down here underneath the 1. Okay, it is shifted 2 units to the left. That means I need some space over here, so I need to move my y-axis over a little bit. Okay, it is positive cosine, which means I'm going to start at the top. Okay, so it's going to go down and up, and that'll be 1 cycle. I want to put 2 cycles on here. The period is 8, which means since I'm 2 to the left, it means I'm going to cross right there. That's 1/4 of a cycle, and 1/4 of 8 is 2. So I'm starting here at -2. I want to make sure I label that. By the time I get to 0, I'm right on the y-axis, and down and back up, and there's 1 cycle. And down and up, there's a 2nd cycle. So I need to label an x value here and here after each cycle. So the period is 8. -2 plus 8 is 6, and 6 plus 8 is 14. Okay, number 6, write an equation for this graph. I need to find out what that sinusoidal axis is. The maximum is 5, the minimum is -1. If I find their average, 5 plus -1 over 2, that will give me the sinusoidal axis. So that's 4 over 2, which is 2. The sinusoidal axis is 2. The amplitude, how far it goes above or below that axis, 5 minus 2 is 3, so my amplitude is 3. The displacement. For displacement, I can use any maximum, minimum, or point on the axis as long as I know the theta value. So I could start here. So I'll use a displacement of 0. I could use a displacement of 1 or 2 or 3. In fact, you know what? Let's not use 0 because that's not even going to show up in the equation. Let's use that 1. We'll use a displacement of 1. So since I'm starting at the top, I've got a positive cosine equation. And then I need b, which is 2 pi over the period. Okay, a period is the horizontal distance of 1 cycle. So I just highlighted a cycle here. From 2 to 4 is 2 units, 2 radians. So b is pi. So my equation is y equals the sinusoidal axis, and it's positive cosine, so plus amplitude cosine brackets, then my b, 2 times theta, and I'm not using an x because this right here is a theta. I want to use theta. Displacement is 1, so minus 1. And there is my equation. We're going to skip number 7 and move on to the back page. Okay, exact value for cosine, 3 pi over 4. So cosine is an x value. On a unit circle, I've got 1/4, 2/4, 3/4 right there. That is 2 positions to the left, so the x value is negative root 2 over 2. Remember, it's 1 over 2, root 2 over 2, root 3 over 2, 1. Same going up, 1 over 2, root 2 over 2, root 3 over 2, 1. Cotangent is reciprocal of tangent, which is x over y. 5 over 3 is the same as 10 pi over 6. So if I go halfway around, that's 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6. Right there. The x value, that is one position to the right, so that's 1 over 2. The y value, that is the third position down. That is negative root 3 over 2. If these denominators are the same, I can cancel them. So I've got negative 1 over root 3, and then I have to multiply top and bottom by root 3. So I get negative root 3 over 3. Cotangent is the same as cosine over sine, cosine theta over sine theta. Since sine is in the denominator, sine theta cannot equal 0, so I need to graph a sine wave. Sine wave starts here at the origin, and by 2 pi it begins to repeat. And there's another half cycle. And by negative 2 pi, I've got another cycle. Since it can't equal 0, anytime it crosses its own horizontal axis, there will be a vertical asymptote. Cotangent wave looks a lot like a series of cube functions that cross right in the middle of each interval, and they have a negative slope. Okay, so now we've got secant theta minus 4. This one is shifted. It's got one transformation down 4. Okay, and secant is 1 over cosine, so that is 1 over cosine theta minus 4. And since cosine theta is in the denominator, cosine theta cannot equal 0. So I need to graph a cosine graph, which usually starts up here at 1, but it needs to be shifted 1, 2, 3, 4 units down. So there at 2 pi, I have completed one cycle. At 3 pi, another half cycle. At negative 2 pi, another cycle. Every time it crosses its own horizontal axis, there is a vertical asymptote. Secant and cosecant is going to look like a series of parabolas with maximums and minimums on the minimums and maximums of the cosine wave. The number of sunspots in a given year varies periodically from a minimum of 10 per year to a maximum of 110 per year. Between 1750 and 1948, there were exactly 18 complete cycles. What is the period of a sunspot cycle? Okay, so we need to know how many years this represents right here. So 1948 minus 1750. That's a total of 198 years. And I need to divide that by 18 because in those 198 years, there were 18 cycles. So that is 11 years for a period. Okay? So there's one cycle every 11 years. Assume the number of sunspots per year is a sinusoidal function of time and a maximum occurred in 1948. Write an equation to match this function. Okay? So I need a sinusoidal axis. That is the average of the maximum and the minimum. 110 plus 10, maximum plus minimum, divided by 2. 120 divided by 2 gives a sinusoidal axis of 60. So if we're graphing this, we've got 60 for the axis, a maximum and a minimum of 110 and 10. Okay, I need the amplitude. The maximum minus the sinusoidal axis, 110 minus 60, and that is 50. I need the displacement. The first maximum or minimum or exact average that I know is this maximum in 1948. So my displacement is going to be 1,948. To write this equation, I still need V, and V is 2 pi over the period, and that's a period of 11 years. So my equation is y equals the sinusoidal axis plus the amplitude. I used plus because we're starting at a maximum, and that's positive. And since we're at the maximum, that's not only positive, but is positive cosine. V is 2 pi over 11. And then I've got, I'm going to use an axis of t for time. T minus the displacement of 1948. Okay, graph this on your calculator and find how many sunspots there will be in the year 2020. So we're going to go to y equals and type in this equation, 60 plus 50 cosine 2 pi over 11, open new parentheses, x minus 1948, and close 2 sets of parentheses. For a window, my lowest year, I could set this at maybe 1900. Let's actually, we need 2020. Let's set that to the year 2000. Okay, and X maximum, I have to go at least as far as 2020. So how about 2040? That'll give us a couple cycles, I think. A scale of 1 might be a little bit much, so let's go by 5. Spread this thing out a little bit. A Y minimum, 0 sunspots up to 110 sunspots. Should give us a good graph. Check the mode, and we are in degrees. We need to make sure that mode is in radians and try that graph again. And that's a lot better. Okay, how many sunspots will there be in the year 2020? Trace 2020, which is actually already there. If it's not already there, I just type in 2020, and I get about 12 sunspots. The first year after 2020, in which there will be about 35 sunspots, so I'm just going to move the cursor along, 16 sunspots, 24, 33, 44, okay, pretty close to that 33. Somewhere in the year 2021, I would expect there to be 35 sunspots.